Okay, let's do a few problems and work through some of the numbers and see if we can make those adjustments. So the first problem, we're going to work on problem setup here. We've got if you deposit $2,400 today and every year for the next 40 years and get an 8% return, how much money we have in the future. Well, so we want to set up this problem properly. The first thing is you always write down the input. So literally write down n equals, I equals, and write down the input. If you're doing a spreadsheet, write down n, I equals, and give them headers and then give them answers. So the idea of writing it down is you know what the input was supposed to be. Therefore, when you get to the calculator and you do your answer, you can be checking to your calculator, hit the recall button in your calculator, and the cell in your calculator, and you should be able to find out if you inputted the numbers correctly if you don't get the right answer. Oftentimes you just hit the wrong button when you input them. So make sure you write down all the information. So in this case, you deposit $2,400 today, and every year for 40 years, you get an 8% return. Well, $2,400 today, that clearly tells me that that's the present value. It's today, so present value equals $2,400. And every year for the next 40 years, so that's payment. So payment will be $2,400 every year for 40 years. There's no adjustment for time period because these are all annual payments. There's no discussion about monthly or daily or anything else. So that's good. That makes it easier. I is 8% return. That's annual. We don't have to adjust for that. So n equals 40. I equals 8. Present value equals 2,400. Payment equals 2,400. And the future value is what we're looking for. And if we look for the answer, we'll see the solution. If we throw it into a calculator, we would get $673,874.50. Notice that the 673 is negative, so the 2,400 present value and payment were in the same direction, and the 673 was coming out, which is a different direction. It does not mean you lost $673,000 in the investment. It simply means that that is in the opposite direction of the payment. So it's important to note that then. So this is one problem. Let's go on to another problem and see if we can make some adjustments here. The next problem is if you invest $200 today and every month for 4 years, get an 8% return, how much money will we have? Well, this is a good question, right? So instead of annualized, let's see if we invest it monthly, if the compounding will have an effect. So in this case, n equals 40 times 12, which is 480 because it's monthly, and the interest rate I is 0.08, or 8 divided by 12, which is 0.067. The present value is 200, payment's 200. Calculate the future value is 703,056. So more compounding periods equals more return. 673 versus 703, you get about $30,000 more for compounding and depositing your money on a monthly basis as opposed to holding it and depositing it over the year. So that more compounding periods, more deposits earlier will give you a higher return. Not much of one, but one that you would still probably want if you could do it. So let's do one more adjustment. Let's do the next one. 30 years. If you adjust for 30 years, you would simply change the payment. It's invest for $200 today and every year or every month for 30 years. All you have to do here is adjust n. If you're doing it in a calculator, instead of hitting 12 times 40 is 480. Instead of 480, you just type in 360. N, compute future value. It would be a very simple way to do it. But this is only a conversion for n. Everything else in the problem stays the same, so that'd be a simple way to do it. But as you know, 30 times 12 is 360. Everything else stays the same, and we calculate it and get $300,000. So what did we just learn? We learned that if we hold our money for another 10 years, we either get 673 or 703. More likely 703. This problem is 703. And if we pull it out 10 years earlier, we only have $300,000. That's a $400,000 difference for leaving your money in the bank for another 10 years, or in the investment, whatever's returning your 8%, which is fantastic. I mean, that's just awesome. This is why everybody says start saving when you're young, because that extra 10 years. Well, if you're already 65, leaving it there another 10 years is very difficult. You have to work until you're 75, and that would be very difficult. So we clearly want to start saving when we're young. The next problem, of course, we're going to make it a little harder on us. We're going to start saving even less, or even later. And so now we only have it for 20 years. So $200 a month for 20 years, we get an 8% return. So we have N equals 240. Everything else is the same. Future value calculated is $118,000. So the difference between 40, 30, and 20 years, you can see very quickly. You could do this on a calculator, and you can see the difference is 40 years you end up with $700,000, and at 30 years you end up with $300,000, and at 20 years you only end up with $118,000, and you're saving the same amount of money every month. So you can see time is a big factor in compounding, and why everyone should start saving when they're early, when they're young, and start saving early because of the compounding. So what we've learned here is, well, let's first of all, we have to decide how we're going to save $200 a month. If you have a 2-household income, no Starbucks on weekdays is $5 per person times 2 is $10 a day, or $50 a week, or $200 a month. So I might not have made somebody's day here, but if you just think of one less Starbucks each for 40 years is $700,000 into your retirement account. If you can average an 8% return, and I know what you're saying, I can't get an 8% return. The average return in the stock market over the last, I don't know, 100 years or whatever the number is 9.6%. So over long periods of time, you can get that return. And there's other ways to get 8% too, real estate and other things if you invest wisely. An 8% return is not unbelievable over a 40-year time frame on average. So, you know, that Starbucks a day is keeping your retirement away. I don't know if we know that, but you can see here that the power of the time value of money is, in very short order, we could calculate 40 years, 30 years, 20 years. You could do all kinds of different things. What if I save $250 a month? What if I get a 7% return? What if I get 6% return? You can see how empowering this is. This is why the time value of money is so important. So we'll keep going. Let's keep going. We've got some more problems.